going through the book 15 Challenging Problems in Probability, and this is number 15, the theta row. 8 eligible bachelors and 7 beautiful models happen randomly to have purchased single seats in the same 15-seat row of a theater. On the average, how many pairs of adjacent seats are ticketed for marriageable couples? So we have 8 bachelors and 7 models. And we want to see on average how many pairs of adjacent seats are ticketed for marriageable couples. Even though it's 2026, this book is defining a marriageable couple as the combination of a bachelor and a model sitting next to each other. I think upon reading this question, instinctively you might want to use some type of combinatorial argument just because it's asking for like arrangements and adjacent seats. And you definitely could, but my solution for this problem was a little more straightforward and computational. So let's draw out the 15 seats that we have. And each one of these slots represents a seat in this 15 seat row at this theater. And let's say we're a bachelor. We're a bachelor and we fix us in any particular seat. Now, on average, what is our expected number of neighbors? Well, let's think about this. You can kind of think of us having a 1/15th probability of sitting at any seat. If we sit here, we only have one neighbor, this seat. If we say we sit here, we have 2 neighbors, these 2 seats next to us. And what you'll actually find is that if you do this for every seat, you'll have one neighbor 2 times, right? So at both of these end seats, you only have one neighbor. And every other time, aka 13/15 of the time, you'll have 2 neighbors. So as you see, we have one neighbor 2/15 of the time, and then 2 neighbors 13/15 of the time. And then to find our expected number of neighbors, it is going to be 28/15. Now, the next step is, of those neighbors, how many are models, right? Because we need, if we're a bachelor, we need our neighboring pair to be a model for us to be a marriageable pair, because that's what we want. We're looking for bachelor model pairs. So let's say we sit here and we choose this specific seat to our right, and we want to know what's the probability that this neighbor to our right is going to be a model. Well, this is pretty simple. There are 14 other people, and there are 7 models. So the probability that our neighbor is a model is 7/14, aka 1/2. And every adjacent seat has a 50% chance of containing a model. Since there are 28/15 neighboring seats on average, the expected number of neighboring models would be 28/15 times 1/2, and that's 14/15. So on average, the expected number of model neighbors we have is 14/15. That's cool. That's for us. We still have 7 other bachelor friends. Well, if we sum all of our expectations together, aka multiply by 8, we get the expected number of marriageable pairs, which is 112/15. And what you'll find is that this actually works if we chose to be a model as well. So say we chose to be a model, the same thing. Our expected number of neighbors doesn't change. We still have 28/15 expected number of neighbors. Now, the probability that our neighbor is a bachelor, right? Because we're a model, we need a bachelor next to us to create a marriageable pair. Well, out of the 14 remaining people, there are 8 bachelors. And what did we do before? We multiplied these 2 probabilities to get the expected number of model neighbors. Now we need the expected number of bachelor neighbors. So we can multiply these 2 probabilities again. And when we do that, we get 16/15. Now remember, this is just for one model, and there's 7 of us. So when we multiply this by 7, we still get the same answer, 112/15. Thank you.